This is LING 270, Language, Technology, and Society, Module 7, Intro to Language Technologies. In this lesson, we'll be talking about electric text. So far we've talked about how text was encoded electronically with Morse code, but in this lesson, what we'll be talking about is how the development of computers led to new developments in the way that text is represented electronically. Encodings were developed which can represent symbols numerically. These are systems which use a number for every symbol in a writing system. Initially, these symbol systems focused exclusively on Latin, but later the Unicode system was developed to represent other symbol systems, including those which aren't just written from left to right and which don't have any diacritics like English does. So the Unicode system is useful because it enables this rendering of different symbol systems and orders, and as well as diacritics. As an aside, before we start talking about encodings, it should be important to understand how computers represent numbers numerically. So the number system that we use in while we're counting and when we're talking about numbers, we use what we call a base 10 counting system. So each numeral in a number counts from 0 to 9, and then once it reaches 9 and increments by 1 again, it goes back to 0, and the next digit goes up by 1. So this is something that we're very used to in our daily arithmetic. And binary is similar to this, but it uses a base of 2. So this is the number system that a computer uses. So instead of having the digits 0 to 9, it just has 2 digits. 1 and 0. And these can be interpreted as pulses of electric current, one of which is on and one of which is off. So this is a way you can interpret how a binary is represented inside a computer. So one binary digit is called a bit, and 8 bits form a byte. So when we refer to bytes, this is what we are talking about. We are talking about 8 of these binary digits. And since, what that means is that these 8 digits can represent numbers between 0 and 255. So if you actually do the math, those are the number of, that's the amount of numbers that you can represent with 8 bits. So some of this might be a review to you, especially if you come from a technical background, but maybe some of you, you may be seeing binary for the first time. So that's why I am going over it here. So now, as you can see, binary numbers can kind of get pretty long since you only have 1s and 0s to represent your numbers. So for that reason, the hexadecimal system was developed as a way of kind of shorthand for representing these binary quantities. So they tend to be very long, but you can shorten them by converting them into a base 16 system. Whereas in our normal numeral system, we count from 0 to 9 and then start over again. In hexadecimal, after 9, you go to A, B, C, D, E, and F, which correspond to the numbers 10 through 15, and then you go back to 0 after that. And what happens is if you use a hexadecimal system, you can convert 4 binary digits into 1 hexadecimal digit. So that makes it very easy to convert between the twos and lets you write binary numbers in a much more compact way. So the binary and hexadecimal systems are very important in character encodings, which we'll see later on. So the first major code for representing letters electronically in a computer system was developed, and it was called ASCII, which is an acronym for the American Standard Code for Information Interchange. It was developed in 1963, and we can see that it uses 7 bits to represent characters. So 7 binary digits can represent 2 to the 7th possible symbols, which is 128 symbols. So that's more than enough for capital and lowercase letters and punctuation symbols as well. Here on the diagram on the right here, you can see how each of these bits in a binary number is mapped onto a letter in the ASCII system. So the way that we can assign numbers to letters is pretty arbitrary. So it becomes important that we all use the same standard. So that way computers can represent a text in the same way as each other. So that ASCII is an example of this kind of standard. But there are some limitations to this, right? Because we only have 128 symbols, and all of these symbols are only symbols of English. There's very little that we can actually represent of other languages. So to address this problem, the Unicode system was developed. So this is a system of encoding which assigns numeric codes for all symbols in all of the world's languages. So not just those of the Latin alphabet. And these codes are organized into what are called planes, which are 2 bytes of characters. So remember that a byte is consists of 8 bits, so 2 bytes has 16 bits. And what that means is that one plane can represent 65,536 characters. So, so if we move from 7 bits to 16 bits, we can represent much more possible characters. And this allows us to represent characters of other languages, as well as just the Latin alphabet. The most commonly used plane in the Unicode system is the basic multilingual plane. That's the plane that you see on the right here. And this defines the most commonly used characters. So those would be the characters of the Latin alphabet, Chinese and Japanese, Arabic, all of the major languages, and many other useful symbols as well. So when we actually see characters like this represented on a computer, it is represented by what the computer actually handles these characters is by a number. And how that number corresponds to a particular symbol is determined by the Unicode standard. So that's the significance of Unicode. So, so Unicode has a way of representing each of these symbols with a number. Now there's now we've talked about this in the unit on typography, where the actual rendering of a letter is called a glyph. So, and Unicode defines the way that these numbers actually correspond to a particular glyph. And what kind of font you use would change the kind of glyph that you actually end up using. And what's important about Unicode, too, is that Unicode doesn't assume that all letters are written from left to right. Unicode symbols can also occur under or above or to the left or to the right. Which is a useful property to have for an encoding system to represent an abugida, such as the Hindi writing system. So we can see in the example on the right here how each of the Unicode symbols in Hindi can combine with each other to be rendered in the proper locations according to the Devanagari writing system. So diacritics is a very useful aspect of Unicode rendering. And as the title here kind of shows, the word diacritics has been obscured with all these extra symbols attached to them. Maybe you've seen this kind of pattern happen before. The way that these symbols are being rendered is through the Unicode process. Each of these symbols is rendered in that way. So Unicode characters don't need to be rendered from left to right or right to left for that matter. And diacritics can be added onto a character and as many as are desired. So this kind of thing is useful for abugidas and languages which have a large number of diacritics. And we can see examples of matres lectionae used in Arabic as well here. So, so here we can see the usefulness of the Unicode rendering process. Another interesting aspect that Unicode is used for is defining how emojis are represented. So beginning in 2010, the Unicode began developing code points, so these numeric representations of these emojis. So an emoji comes from the Japanese word emoji, meaning a picture character, which literally translates to pictogram. This brings us back to module 1 here. And the similarity between this word and emoticon is actually entirely coincidental, so that's an interesting thing to consider. So Unicode version 12 actually represents 1,311 emojis. So quite a wide array of emojis here. And emojis we've been finding, especially in the digital medium, are very critical for adding affect to text. So the way that we express our emotions in speech is kind of lost when we use things in a text medium. So emojis have become a really important way of expressing yourself, especially in the internet, for example. So think, for example, about how you would express something emotionally or express something sarcastically. An emoji or some kind of representation like that would be very critical in getting your meaning across. And there are many emojis of which have been developed that have double meanings to them. These so that kind of further shows interesting processes of linguistic development over time. So here we can see how the Unicode code points actually correspond to the emojis on this little table here. And we can see how they are rendered in different glyphs depending on what kind of platform you're using. If you're using it through Apple or Google service or what have you, we can see all these different kind of renderings. Now, emojis have a very interesting kind of cultural impact. So they've become a significant way that we express ourselves in regular discourse. And what was kind of interesting is that in the year 2015, the most famous word of the year, if we can call it that, was the what's called the face with tears of joy emoji. So this is the emoji that is actually used the most frequently compared to all the other emojis. Now, yeah, so this kind of goes to show how important and how really, I guess, novel emojis are on the online communication. And it's also kind of interesting how the effects that the use of emojis has become. So currently, it's been a legal issue as to whether emojis can be used as evidence in court. So we've seen how emojis can change the meaning of a text, and that would become very important on a lawsuit that depends on personal communications, which contain emojis in it. So we can see that the importance of emojis is actually taking on legal significance. Another interesting phenomenon is that in India, WhatsApp was sued for violating the India penal code because of its middle finger emoji. So we can see how some things can be expressed kind of offensively using emojis, and it's becoming more of an illegal issue there as well. And we also see some interesting patterns of emoji use across countries. So we can see that different countries have associated different meanings with different emojis. So kind of in the same way that people associate different meanings with different words. So regions such as Austria, France, and the Czech Republic tend to use more happy emojis compared to other countries, for example. So we can see that even this recent development of emojis enabled by the Unicode system has actually become pretty widespread and has become a pretty significant issue. So to summarize, we've talked about how the initial way that characters are represented, at least for the Latin alphabet, was the ASCII system, developed in 1963, and it represents symbols with only 7 bytes of information. But only representing the Latin alphabet isn't very useful in many cases. So because of that, the Unicode standard was developed, which can represent many other languages. And it's large enough that it can actually represent things like Chinese characters and Korean letters as well. A key benefit of the Unicode system is that it separates the encoding process from the rendering process. So what that means is it allows us to type symbols in which occur in various orders or which might occur above or below a symbol very easily. Think of how the Hindi writing system is written and things like Abhidas are written. So the Unicode rendering process is very critical for that. And Unicode can also represent things like emojis, which is becoming increasingly significant in digital communication as a way of conveying affect. So here we can see how digital text has kind of been invented and developed.